So we start with energy, and some bit of talk I had done with you guys saying that energy is the ability to do work. As much as energy you have in your body, so you will work. Okay, energy. Energy and work in physics are interrelatable terms. If you do work on a body can do work if it has energy, right? And if you do work on a body, then you are actually adding up energy to that body. You can't create energy, nor can you destroy energy. You can just convert it from one form to another. So as a basic, we know energy is the ability to do work. There are various forms in which we can do work, right? Heat energy you can use. So when we study in mechanics, we will be typically studying about mechanical energy. Now if you ask me, sir, how do you define mechanical energy? Energy used to do mechanical work. What is mechanical work? In broad sense, just remember something. Anything that moves is finally due to mechanical energy. That movement can be a rotation, that movement can be a translation. You know what is translation? Like when you slip and you go away, that's translation. Anything which is rolling, anything which is getting lifted, anything which is drilled down is all mechanical energy. Now, how do you do that? You can do it by using your muscle strength. Then you are using muscular energy, you are converting to mechanical energy. You use a drill machine, then you are using electrical energy. To power the drill machine, if it is a handheld drill machine, then you have got batteries in it. So chemical energy is getting converted to electrical, electrical to mechanical. If you have solar driven drill machine, say suppose, which is not there, so the solar energy is getting used. You see windmills, so there we are using wind energy. Then on high tides, when tides come, you use tidal energy. Then the energy of the earth is also used, geothermal energy. So in broad sense, you might be asked about giving some examples in this chapter. Name a device that converts electrical energy into mechanical energy. Fan, drill machine, lawnmower, electrical, shaver, you use electrical energy, trimmer, there's a mechanical energy, something is rotating, the blade is rotating. Have you seen a trimmer? The blade rotates. Name a device in which chemical energy is converted to heat energy. Chemical energy to heat energy, you can straight away say burning of coal. Chemical energy is being converted to heat energy. Nuclear energy to heat energy, or nuclear power plant. Uranium, uranium is nuclear energy, right? But our concentration in this chapter will be on mechanical energy because we are learning about mechanical work. So far we studied work done, work done, work done. But how did you do the work? How did you pull the cart? You must have spent energy. Only then work can be done. They are just like, as I told you, like gold and money. If you buy gold, your money reserve has to come down. And if you're selling gold, your money reserve will go up. Okay? So our study is all about mechanical energy. And quite a few questions come from here. Mechanical energy. And mechanical energy, we study two types of energy. The first one we will study today, we'll first take a dive at is kinetic energy. Okay. And when you see the word kinetic, kinetic theory of matter, kinetic Honda, kinetic anything. Kinetic means anything that moves. Kinetic theory of matter, like particles are moving. Kinetic मतलब movement सोचने का. So kinetic energy. So if I go by definition of kinetic energy, then the simple definition is energy by virtue of motion. By virtue of motion. क्या क्यों ये energy आपके अंदर क्यों है? Because of motion. If you don't have motion, you have no kinetic energy. So let us try and understand. Let's say I have a ball and this ball is rolling on the ground. This ball is rolling on the ground. Does it have energy? Yes, it has energy. How do you say? Make this ball hit any object, it can displace the object in the direction of the force. So it can do work. A question arises, sir, what sort of energy is this body having? This body is right now having kinetic energy. Kinetic energy means any body which is in motion possesses kinetic energy. Sir, at that time, can it possess some other form of energy? Yes. But kinetic energy is ensured. मतलब जब आप मोशन में हो, kinetic energy is there. So let's ask the converse question. A body is stationary right now. Does it possess kinetic energy? No. Does it possess energy? Yes, it might possess energy, but it does not possess kinetic energy. So we write kinetic energy is the energy possessed by a body by virtue of its motion. So you can also write, if a body is in motion, it is guaranteed that that body contains kinetic energy. It can contain other energies also, but it will contain kinetic energy. A body in motion has kinetic energy. K. A body in motion has got kinetic energy. And if you have kinetic energy, then body can do work. What did we understand for work? A body can do work if a body has got energy in it. So if you are having kinetic energy, then you should be able to do work. Now comes our job for deriving an expression for kinetic energy. How to find out? हाँ बोलो बेटो. Virtue. By virtue of क्या बोलो virtue? Due to. Virtue means due to. By virtue. हाँ. By virtue of motion is known as kinetic energy. ठीक है? Let's now go for the derivation of kinetic energy. The expression for derivation of expression for kinetic energy. हाँ, इसका भी derivation है. अभी से welcome to the world of derivation. Expression for kinetic energy. Now we have to understand it first, and then only you will understand the derivation. What about Ryan? He's not come? Oh, he's sick. Okay. So let's see the derivation of kinetic energy. Okay. Let's try to understand first. Let's try to understand. Okay. First try to understand. I'll write everything. I have a body, and this body has got a mass. I have a body, and the body has mass m. M is the mass of this body. This body is right now having a velocity which is given by v. Right? It has a velocity which is given by v, and obviously the body is moving. This body now penetrates some medium. It can be air, glycerin, water, mud, slimy cow dung, whatever you think. This body is trying to. In grade 8, I always give all examples with. They learned matter that way. Define matter. Matter is like soft cow dung in your hand, something that has mass. You can feel it, occupies space. Okay. So this body is getting into a medium. This is one medium. Okay. So let's cook up our story first. We want to measure its kinetic energy. Now, how do we measure kinetic energy? This body is entering in this medium. As soon as it enters into the medium will give some sort of obstruction to this body. Imagine that this is some water or the other thing, right? So let's say that this body, when it enters into a medium, it starts facing a obstructional force. Okay, it starts facing a force against its direction of motion. It starts facing a force against its direction of motion. As a result of this, our body will be actually getting inside this medium, and after some time, what will happen to this body? It will slow down and it will stop somewhere here in this medium. Don't you think it should slow down? Very easy concepts. Okay. And the distance or the displacement that this body is actually traveling. Now, why am I saying displacement? Because somewhere we have to equate work also. Okay, so let's say this body travels from here to here, right? And this displacement that the body undergoes in this medium, let this displacement be s. And here the body comes to a stop, mass still remains m, and its velocity here is 0. Have you understood? Right. Now, as soon as the body gets inside this medium, this force starts objecting the body. Or not objecting, obstructing the body, right? So if the body still travels on this direction, the body must be giving a force which is equal and opposite to this. Then only the body can come inside. So the body comes inside, and in this way, the body must be doing some work. What is the work? The force with which the body is entering multiplied by this displacement. If I can calculate this work, This work is nothing but the kinetic energy of the body at this moment. Why did it stop here? All kinetic energy got converted to what? To work. When a body comes to rest, does it have kinetic energy? Hey Mishka, kya ho gaya? When a body comes to rest, does it have kinetic energy? No. Here it has kinetic energy. So can it do any work out here? No. So it must be doing some work from this point to this point. How are you able to do work? We can do work only when we have energy. Right now the body possesses what? Kinetic energy. It is unable to do any work out here. From here, no more work. So all the kinetic energy that the body had that body must have spent all that kinetic energy. Do you agree or not? It has spent all the kinetic energy. So if we can measure what is the work done, that should be equal to the kinetic energy, right? So that is the gist of our derivation. So see first. Don't immediately start writing. Enjoy the derivation. So we say consider a body, okay, where we have mass m, right, and it has a velocity say v. There's a velocity v, and this body enters a medium, then slows down. Slows down means what, children? What should you think from here? Slows down means retardation is happening. Please keep it in mind. Retardation is happening. That means a negative acceleration is acting because this force is opposing you. So the acceleration is also in the direction. So the body slows down and then comes to a rest, right? Undergoes a displacement which is equal to S. इतना ही तो story है. I have a body of mass m which enters a particular medium. तो यार क्लास में छोड़ना, पेन छोड़ना, ये तो वीडियो रिकॉर्ड हो रहा है ना, घर में जाके इसको दोबारा बनाओ, पहले एंजॉय करो. आप समझोगे why are you all unable to write, because you all don't listen. First listen. At home, you in grade 9 you cannot say that I studied in tuition means done. No. At home you go back, you have your textbook now and the video now and try to spot out, sir आपने कुछ गलत बोला था. पहले समझो चीज को. The body undergoes a displacement which is S. Right? Now, so this is what is the scenario that is happening. So all understood. This is understood. This is my first part, whatever I say, consideration part. Number 1 part gone. Let's see the number 2 part. Right? An opposing force F acts opposite to the motion of the body. And this retards the body with an acceleration which is negative A. Now you yourself ask, why negative A? Because the force is acting against you, so the acceleration will be negative, right? Now our thought process. Third, the body does some work to move S displacement. It has to do some work. And let's say this work is equal to force into S. Some force into S. And this force should be exactly equal and opposite to F. मुझे कोई oppose कर रहा है, फिर भी I want to enter, so I have to oppose that force and get inside, na? Which is equal to that force. Did you not go into that example where we said when a man lifts or walks up, why do you sweat? Because you're pulling up your own weight. You have to pull up your own weight. If you don't pull up your own weight, ultimately you will remain below. So the body applies a force which is exactly equal and opposite, right? This. And then fourth point I'm writing, this work is done by spending the Ke of the body. How did the body do this work? To do work, you need energy. This work must be done by spending the kinetic energy of the body. So our nice thing is, if we can calculate work, then we can get the value of kinetic energy. This is our target. Now we'll get an expression for this work, and that should be the kinetic energy. Now try to see this thing. Anything that you have not understood here? Understood? So this becomes my part 2, which I'll also make small, and I'll keep it. ठीक है, इसको भी छोटा कर लेते हैं और इसको यहाँ पे रख देते हैं. Round 2 of your derivation. Okay, and then you will get your time, don't worry. So this is part 2. Now part 3. Let's see part 3. Work done. Work done is what? W, which should be equal to F into S. Clear? No issues? Fine? Okay. Now, say from this point A to this point B, right? From this point A to B, I write the travel from A to B qualifies. देखो कितना interesting है mechanics. Qualifies for SUVAT. You know what is SUVAT? It qualifies for SUVAT. This is a straight line motion, uniformly accelerated, though it's a uniformly decelerated, and in a straight line. That means equations of motions are applicable for her. Okay, so it qualifies for SUVAT. So let's bring out the third equation of motion. What is the third equation of motion? V square is equal to U square plus 2AS. Do you agree? फिर पेन ले रहे हो. V square is U square plus 2AS. This is final velocity. In my problem, this is 0 because the body has come to a stop. The U square is V square because this is the initial velocity. Right? The A is a negative A and the S is S. Right? So shall I apply my law out here? So in my case, it will be 0 square is equal to V square minus 2AS. Or from here I can say A is equal to V square divided by what? 2S. Do you agree? A square divided by 2S. Very good. Let's make this also small. Small, small, small. Right? Small, small. कौन सा? बॉडी चला गया क्या? कोई बात नहीं, तो छोटा करते हैं. So many pieces of bread we have toasted. See, this is number 3. Number 3. Okay. हो गया ना? Derivation तो आ ही गया है अभी. So let's go by this. Work is equal to force into displacement. Force can be written as ma, or acceleration into displacement. Can I write this? So work is equal to m. In place of acceleration, what do I write? V square by 2s multiplied by s. S cancels. So the work is equal to half mv square, which is equal to the kinetic energy. So from here you get the definition and the derivation for kinetic energy. I'll give you all time. Kinetic energy of a body is half mv square. अब देखो तुम्हें कितना समझ में आया. अब तुम आराम से लिखो, तुम्हें जितना टाइम चाहिए. नहीं समझोगे, मैं समझा के लिखाऊंगा. आप अपना टाइम लेके लिखिए. But understand the story. So this is your 4th part. And the SI unit will be what? Joules. Because this is energy. What was the story? The story is that the body has done some work and it has come to a rest. If it has come to a rest, its kinetic energy has become 0. That means whatever kinetic energy it has, it must have spent. What did it spend it in? It spent it to do some mechanical work. So if we, and what is our mission? our mission is to calculate the kinetic energy of a body. We can't find it directly. So what did we do? We will start to see. We want to find out how much money Mishka has, but you are not showing your money. So we added up all the bills of items that you bought. That must be your money, right? So we tried to calculate what is the work done by the body. If we know what is the work done by the body, then that is work done is what? Force into displacement. One doubt in your mind will be, why did sir say sir is showing force on this side? This is the opposing force. If I have to penetrate inside, I have to overcome this force by an equal and opposite force. So force into displacement. And since my force is acting opposite, so the acceleration is also opposite. So what I do, I first put it as F into S, then I put the third equation of motion. I find a relation for A, I substitute A in that expression and I get my half mv square. खत्म. अब आप लाइफ में नहीं भूलेंगे. क्या हो गया, लिख भी नहीं रहे हैं? बहुत बढ़िया, कोई बात. बोलो बेटो, कोई भी चीज नहीं समझो, आई एम देयर टू हेल्प यू. कौन सा? You tell me. Second, this one. Okay, first one. What do you? Okay, first is what? First is all consideration. You see, consider a body. Which body? This one. Mass is m, velocity is v, enters a medium. Okay, slows down, and therefore I put a smiley. Slows down means it undergoes retardation. So a negative a. This you should keep in your mind. Then ultimately comes to a rest. And undergoes a displacement s. पहले हमें बॉडी के बारे में, बॉडी ने क्या क्या किया? Body's mass is m, coming with a velocity v, entering a medium. After entering the medium, it travels straight line, that means some displacement, and is encountering an opposing force, so it slows down, retardation, and finally its velocity comes to 0. अगर ये कहानी आप you write it in your order, you only think and write it in your order, आप गलत नहीं करोगे. हो सकता है I wrote velocity first, you will write velocity last. और वो नहीं होगा तो फिर तोता हो जाएगा. अभी नंबर 2 देखें. 1 हो गया. Shall we see what is happening at 2? At 2 I am saying an opposing force F acts opposite to the motion of the body. Do you agree? An opposing force F acts opposite to the motion of the body. So what does it do? Retards the body with an acceleration negative a. Clear? These two lines. Then the body does some work to move this displacement s. And that work is given by W equal to force into displacement. This force is exactly equal and opposite to the force with which you are encountering. And this work is done. How are you doing this work? This work is done by spending the KE of the body. अगर उसने यहाँ से यहाँ तक थोड़ा सोना खरीदा है तो कहाँ से खरीदा है? जो पैसा उसके पास है उसी से तो खरीदेगा. By spending. So this gives us a conclusion that the work is equal to KE. If we can calculate work, we can be able to calculate the KE also. Any doubt in this section? No. Once you are done, we'll go to 3 together. Up till 2, you just check whether you have understood. Anything you have not followed, I'm there. Done? Shall we go to section 3 now?
So once the third
Which one?
by वो second वाले
किस section में बोलो बेटा?
वो third last
हाँ, so it says
the next
one. The work is done by spending the kinetic energy of the body. By spending the kinetic, or at the expense of kinetic energy. You use better English. Or by draining the kinetic energy of the body. आप में जितना दम था आप उतना ही दौड़े। चले अभी 3 पे। तो 3 में what we have done? 3 is we now need to do our calculation. Work is equal to F into S. Right? Work is F into S. Then you stop there. Then you see that the travel from A to B qualifies for SUVAT. You know what is SUVAT? So you can rather in SUVAT you can also put in SUVAT you can also put uniformly, yes, very good, accelerated motion in straight line. This is what is SUVAT, uniformly accelerated motion in straight line. That means third equation of motion can be applied. I can apply anyone, but I need to get out. See, ultimately, this force is not known to me. How do I know what medium is giving how much force? Displacement is something I can still measure, but every time you cannot have displacement. See, when you are getting now the question arises, sir, why did you do all this jing bang, or what did the book do? Go back to the definition of kinetic energy. Energy by virtue of motion. I am in motion. What is the maximum information you can have about me? My mass, my velocity. How do you know I am entering mishti doi, or I am entering kheer, or I am entering glycerin? How will you calculate what is F and what is S? You have to come to a generic term. That means the F has to be abolished. The S also has to be abolished. And we need to come in terms which you can tell about a body. If he is moving, I can always say what is his mass and what is his velocity. Those are the easiest thing to quantify for a body in motion. So to do that, I am now bringing this third equation where I say V square equal to U square plus 2S. V is the final velocity. In this case, the final velocity is 0. Initial velocity is the velocity with which you entered the medium. ठीक है ना? आगे क्या हो गया? फिर कहाँ सोचने चले जाते हैं? फिर से यहाँ से बाहर हाथ नीचे. And then A is negative. ठीक है? अरे मैं लिखूंगा मम्मा को, रुको. सब वो लिप बाम. हाँ, नहीं तो सेलो टेप मार के रख दूंगा यहाँ पे मुंह में. 0 is equal to V square minus 2AS. So A is equal to V square by 2AS. 2S. Still the S needs to be knocked off. But you have an S out here and you have created another S at the denominator. So W is equal to Fs. W is equal to M into A. What is F? M into A into S. A के जगह में V square by 2S डालो. S ने S को काट लिया. So half mv square. But still you should check, is half mv square really representing work? मैंने बोला है. We should check from the units perspective also. What have you learned about work? What have you learned about work so far? Work is equal to force into displacement. Just check. What is force? Mass into acceleration. So acceleration will be meter per second square into second. That means second gone. That means work is kg meter per second. Work is kg meter per second. So let's see, half mv square. Okay. Force, no. Sorry, I have done a mistake. Work is force into displacement. Sorry, children. Force is mass into acceleration meter per second square multiplied by displacement, which is also meter. So I should get kg meter square per second square. Now just look at kinetic energy. Half, so half is a scalar, mass m kg into v square. V square is meter square per second square.
Yeah.
That means we are found out energy only. ऐसे आप चेक भी कर सकते हो कि आप जो निकाल रहे हो वो एनर्जी है तो. So anytime your formula goes wrong, you can always check it by units, whether you're doing it the right way or not. ठीक है, चलें आगे. थोड़ी और स्टोरीज देखते हैं काइनेटिक एनर्जी के बारे में. आइए. कैन आई चेंज द स्क्रीन? अच्छा, understand each section whenever you are learning from any video or any screen. Then try to write that section in your own words. Then you will not have the habit of copying word by word. Once you have understood, at the end of the day, you have to narrate the same story. He went to the market, he reached out to the market. Nobody will give you something wrong on that. Chale? Okay. Now let's look at the expression for kinetic energy. So kinetic energy. K is given as half mv square. ठीक है, खाली बात करते रहते हो तुम लोग. Half mv square. So if you look at this expression in a proper manner, you can say the kinetic energy is directly proportional to the mass. Right? With the same velocity, if a bull is coming and a butterfly is coming, the bull carries much more energy with it because its mass is more. Understood? And the kinetic energy is proportional to the square of the velocity. That's the reason a bullet actually causes so much of not pain, damage. The bullet's mass is less, but the bullet's velocity is very high, and the energy that the bullet is carrying is directly proportional to the square. Ek to high velocity, now it will depend on the square of the velocity, not double, square of the velocity. Therefore, the bullet has a capacity of doing a lot of work. It can actually penetrate inside the concrete. Now, do you correlate? Think, replace that ball in the previous diagram with a bullet. तोड़ के चला जाएगा. समझ में आया? अब देखते हैं. Let's say I have a body. Scenario 1. Now this ये question बहुत आता है. Scenario 1. The mass of this body is m and it is moving with a velocity v. This is scenario 1. Then what is the kinetic energy Ke1 of this body? Half mv square. Agreed? Let's see scenario 2. Scenario 2. I have a body whose mass is now double the mass of this body, but it is moving still with a velocity of v only. Let's see what is the kinetic energy of this body. Ke2 is equal to half into 2m into v square. Do you agree? Half into 2m. From here, what I can do, I can take half, right? Sorry. I have taken the 2 outside. I have taken the half and mv square. That means it becomes 2 times of Ke1, Ke2. So this is a very interesting finding. और ये आपको पूछेगा. Show that if mass is doubled, kinetic energy gets doubled. Did you understand how we proved it? V square होगा. हम back किया था ना. So Ke2 is half into 2m into v square. Take the 2 outside, then it is half mv square. And half mv square is Ke1. Therefore, Ke2 becomes 2 times. So we write here, if mass is doubled, Ke is doubled. If mass is doubled, then Ke also gets doubled. Okay? Let's see scenario 3. Scenario 3, I have the same mass, but it is now moving with a velocity 2v. It is moving with a velocity. We have doubled the velocity now. So let's see what is the kinetic energy now. Ke3 should be equal to half into m into 2v square. 2v square. So how much do you get? You have a half, right? So let's do it in this manner. Let's keep our half as half m. Let's keep the v square here. And because of the 2 square, you get a 4. Are you fine? Half, I have retained half. M, I have retained m. V square, I have retained v square. And the 2 square, I have brought 4 out here. So this becomes how much? 4 times of Ke1. This is another interesting finding for a bullet. So here we see, if the velocity is doubled, Ke increases 4 times, quadrupled. If velocity is doubled,
Both of them are double.
then it will be increasing much more. If velocity is doubled, Ke is quadrupled, or you write Ke is 4 times. Ke increases 4 times. So if both of them are doubled, what will happen? See, if both of them are doubled, you will get a 2 from here and you will get a 4 from here. 8 times. 8 times. तो ये क्वेश्चन आता है कॉमन. What happens to the kinetic energy, and show and tell what happens to the kinetic energy if the velocity is double. So if velocity is double, kinetic energy increases 4 times. Acha, if somebody is little bit wants to take swath of you, then a scenario 4 can be created where the mass is m, but the velocity is halved. The velocity is halved. So let's see what happens in this case. Ke4 will be equal to half into m into what, beta? V by 2 whole square. So I will retain my half, my m, v square, and 1 by 2 whole square is how much? 1 by 4. So this is 1 by 4 into this. So this is 1 by 4 times Ke1. But interesting hai, dekho. So here you can say, if velocity is half, kinetic energy becomes 1/4 of its original. If velocity is half, Ke becomes 1/4 of original value. And if mass would have been halved only, then half of the original value. If only mass would have been halved, then it becomes half of the original value. वो भी करके दिखाओ, कर पाओगे? क्यों इतना जल्दी मन क्यों खराब कर जाता है? Yeah, no scratch, बच गया. So see scenario 5 also. Scenario 5. So we have now mass. नहीं, और वो नहीं करते m by 2 and the velocity is v. So Ke5 is equal to half into m by 2 into v square. So you retain your half m v square and you bring the half out here. So this is half Ke1. That means if mass is halved, the day it doesn't rain, it becomes pura humid. It's very sultry today. Yeah, sure. If K is halved, if mass is halved, K is halved. If mass is doubled, K is doubled. If velocity is halved, K becomes 1/4. And if K is, so if somebody asks you a question that the velocity of a body has been increased to 3 times, what is the impact on its kinetic energy? 9 times. Not double, square. इतना पढ़ाने के बाद यही है. सीता होता फिर कह रहे हो सर सीता का क्या हुआ सर? सीता वो गई थी पांडवों के साथ वनवास में. हाँ वो वैसे ही पूछा ना. She is saying double. Velocity has a square relationship. If you make the velocity 3 times, kinetic energy becomes 9 times. If you make the velocity 9 times, kinetic energy becomes 81 times. Yes. And if you halve the velocity, then the kinetic energy becomes 1/4. And if you would have made 1/4 the velocity, the kinetic energy will become 1/16. Very good. 1/16. ठीक है. ये इतना मुंह टेढ़ा करके मत पढ़ो. देखो ज्यादातर घरों में क्या होगा, like say if you are a 100% sample, 75 to 78% of you people will be pushed to MPC, whether it is parents, relatives, friends, peer pressure, dunyadari, or the ability of not being able to decide what do I want to do in my life. And there the same lady will be waiting for you. Come, I am kinetic energy, so don't make a face with them. ये तुम्हारे साथ रहेंगे. And you don't have the option to go back in your career now to grade 4 and grade 3. right? The next 5 to 6 years, you are just like you have driven 2000 kilometers in expressway and you'll be now getting into ekdam full traffic, puta puta rasta. You need lots and lots of motivation and self belief and lots of courage. आगे वाले दिन, मैं वो टीचर हूं जो सच बोलूंगा आपको, आने वाले दिन बुरे आ रहे हैं जब तक आपका 12th के बाद आप कहीं सेटल नहीं हो जाते। एक बार सेटल, हैव यू हर्ड एनीबॉडी फेलिंग इन इंजीनियरिंग और मेडिकल? नो, नोबडी फेल्स। घुस गया तो निकलेगा कहीं ना कहीं। इट्स लाइक योर बॉडी, यू हैव ईटन समथिंग, द ह्यूमन बॉडी कैन कीप एनीथिंग, यू नो दैट राइट, इट विल कम आउट। आप इंजीनियर हो या डॉक्टर होके निकलोगे, लेकिन वहां घुसना। हाँ बोलो। कौन सा सेंटेंस? ये आपको सेंटेंस से क्या लेना था, आप समझ गए हो ना। मास दुगना करेंगे, काइनेटिक एनर्जी दुगना होगा। मास आधा करेंगे, काइनेटिक एनर्जी आधा होगा। वेलोसिटी दुगना करेंगे, काइनेटिक एनर्जी 4 गुना बढ़ेगा। वेलोसिटी हाफ करेंगे, काइनेटिक एनर्जी 1/4 होगा। ओके, इसमें earlier days grandmothers used to cook so many recipes. Did they join any culinary classes? No. How did they know that in this one this masala goes, in this one this goes? How do they know? That's because they learned it. आपका learning नहीं हो रहा है ना, learn करना सीखो। You know so much of algebra and mathematics, right? I'll tell you one case. Papaya is priced at 65 rupees a kilo. अब ऐसा थोड़ी है कि जो पपाया आप उठाओगे वो 1 किलो ही होगा या 2 किलो होगा, ऐसा तो नहीं। That papaya is 750 grams. Shopkeeper calculates faster than you. That day you should be actually CBMDM. चुल्लू पर पानी में डूब मरो. After doing so much of polynomials, the shopkeeper calculates faster than you. Why? आपको नहीं आता है ना, कर पाओगे? Or else you be like my sister. My sister goes to the shop and says, ऐसे पपीते उठाओ जो या तो आधा किलो हो या 1 किलो हो या 2 किलो हो। Means she wants everything in multiples of 500 grams. The shopkeeper gets fed up and says, मैडम जी आप ये ले लो, ये 2 किलो ये ले लो, so that the calculation is easy. You buy a fish, the fish is not going to be exactly 2 kilos or 1 kilo na, it may be something like 900 grams. How do you calculate? नहीं आता है ना, लेकिन क्या है, आप कैलकुलेटर चलाते हो, नहीं आता है, तो वो सीखा है, he has learned. Same is with language. What's your second language? French, German? Can you follow a second French movie? Can you take a taxi from the airport, Charles de Gaulle airport in Paris? No, I can't. But you look at the Marwari guys sitting in Abids and Koti. They are selling saris to Telugu ladies, freaking fluent Telugu. They have learned language. They are using language to their benefit. आप खाली जब जाते हैं बस स्टॉप में, या आई हैव पुट यू नो आदिया आल्सो नाउअडेज शी इज इनटू फ्रेंच एंड, मतलब काफी हेल्प होता है ना। जर्मन एक लैंग्वेज, बच्चे को जर्मन में कुछ नहीं आता है, खाली गुटन टैग और गुटन मॉर्गन बोलना आता है, उतना तो मैं भी जानता हूं। चलो चलें एक प्रॉब्लम करने की कोशिश करते हैं, चलो देखते हैं। सो देयर इज अ कार, द मास ऑफ द कार इज 1500 kg. The car has a initial velocity of 20 meters per second, has a final velocity of 30 meters per second. Calculate work done. देखो फंस जाओगे तुम इसी प्रॉब्लम में। Calculate work done. Calculate work done. Work done. Work done हम क्या पढ़े थे? Force into displacement. डिस्प्लेसमेंट तो बताया ही नहीं क्या है इसमें, फोर्स बताया ही नहीं क्या। Who said the car it is going in straight line? Did I say that? Again, you are not putting the basic of the learning today. What have I asked you to find out? Calculate the work done by the car. The car is doing some work. So if a body does work, then what happens? The energy of the body should go up. So if I apply Ke final minus Ke initial, this gives me my difference, which is called, this gives me what is called my delta KE. KE final minus KE initial, right? And in this case, the half m is common. The final velocity is more, right? It will be 30 square minus 20 square. That means there's a gain of energy. How did you gain this energy? Because this much of work was done on you. This should be the work done. क्योंकि आपका दिमाग वर्क मतलब फोर्स इंटू डिस्प्लेसमेंट ही सोचता है, ऐसा नहीं है ना? कौन सा नहीं समझ में आया? डेल्टा मीन्स अ डिफरेंस बाबा. Has the velocity increased of this car? So has the kinetic energy increased? Kinetic energy is by virtue of motion. Your motion has picked up. So your kinetic energy has picked up. आप 20 की स्पीड से जाके अभिज्ञा को धक्का मारना और 30 की स्पीड में जाके धक्का मारने में कहां चोट ज्यादा लगेगा? 30 की स्पीड में. मतलब आपके पास एनर्जी बढ़ गया है ना. So your change in energy is what? Change means what? Final minus initial. Final KE minus initial KE. Every KE is half mv square. Array. This is equal to half mv square minus half mu square. तो यहां से हाफ m कॉमन नहीं ले सकते, तो अंदर क्या हो जाएगा? v square minus u square नहीं हो जाएगा? Now again a question. v square minus u square is what? 2as. 2as. वहीं से ये वर्क को भी रिलेट कर देता है. v square minus u square is a 2as in a straight line motion. Yes or no? No? 2as. See? अच्छा, what is this? अच्छा, see. बच्चा मजा लो क्लास का. ये देखो, ये क्वांटिटी क्या है बेटा? 2as. Don't you think so? यहाँ ध्यान दो ना, यहाँ ध्यान दो. This is what? 2as. What is this? Half. What is this? m. हाफ ने 2 को काटा, m और a से पैदा हो गया f और s आ गया. तो यही तो वर्क है. अब स्कूल आपको बताएगा भी नहीं, आप इसको ऐसे ही देखोगे भी नहीं. आप सिर्फ तोते की तरह प्रॉब्लम करते हो. देन यू विल से, hey, how much did you get? I got 290. You got 290? Yeah. No, I got 390. Oh, my bad, I made that mistake. You actually solved only a हिसाब किताब problem. You didn't learn the beauty of physics. v square minus u square is a 2as. ना रे भाई, आया समझ में? हो गया? 3,75,000. Is that the calculation that you found out? 3,75,000. Now itna joules. There is not a right way to represent it. 3,75,000. So how can we write it? We can write it as 375 kilojoules, or we can write it as 0.375 megajoules. 10 to the power 6 kilos next is mega, megas next is gigas next is tera, 1 TB. 10 to the power 3 is kilo, 10 to the power 6 is mega, 10 to the power 9 is giga. Exactly the small 10 to the power minus 9 is nano. Giga, nano, mega, micro, kilo, milli, tera, peta. Peta. 10 to the power minus 12 is peta. 10 to the power 12 is tera. I have a 1 TB hard disk. What does 1 TB means? 10 to the power 12. Exa, peta, tera, giga, mega, kilo, hecto, deca, deci, centi, milli, micro, nano, pico, femto, atto. Not peta, pico, sorry. I said peta or what? Yeah. No, not peta, pico. कब सीखोगे? When? ठीक है? Our next form of energy, just 2 minutes more. Ish, why is it every time striking me? Our next form of energy is known as potential energy. We'll just see the definition part. Again, we have a derivation here also. Potential energy. So this is energy possessed by a body by virtue of its position or constraint. You have to understand. By constraint, position or constraint. If a body, due to its position, has energy in it, first let us understand position, right? Now let's say our friend Rayans sitting on the floor and Rayans sitting on the table. On the table, he has energy because of this position. If I push him down and he falls on an atta dough, he can actually pitchko that atta dough. Do you agree or not? So that's a position. Have you understood? Any time when you're by position, because of that position, he has energy. Higher you are, more is the energy in you, and more is the energy, more unstable you are. Have you seen Maruti Omni, the Maruti van? क्या Maruti Omni नहीं देखा है? Don't give me all those answers. The Maruti Omni is a vehicle which is having a shape like this. Have you seen this? That the door just opens up. Okay. Maruti Omni, when it came up in the year 1985-86, it came up with two models. One model was called the flat roof model, which you nowadays see. Another model was the high roof model. One was like this. And this vehicle was used a lot in Bollywoods for only showing kidnapping scene. Means it stops, it opens, and kidnap happens. Maruti discontinued this vehicle. Shape. The height is more. So on curves and other places, ये stability कम है इस गाड़ी का. Are you understanding? जैसे इसके ऊपर में हमने कुछ रख दिया ना. The more at a height you are, the more unstable you are. As simple as that. So to make any object stable, its energy should be as low as possible. That's why when you go to Bombay or any place which has got double-decker buses, if you don't have passengers on the ground floor, the conductor will not allow you to occupy the top floor because the CG of the vehicle has increased. More the CG increases, more will be the chances to topple. Even all these buses which you see, the sleeper buses, the sleeper buses में ऊपर तभी सुलाएगा आपको जब नीचे लोग हैं. Otherwise, you have moved the CG of the center of gravity has gone up. Chances of the bus to topple is much more now. Have you understood? That's why I said, if I make you sit on the floor of the bus, you feel confident. On the chair, on the seat, you're still unstable. Standing, you're very unstable. I make you now stand on the roof of the bus, terrace of the bus. So that means your energy is very high. So these are called energy by virtue of position. अगर किसी position में रहने के लिए पानी in an overhead tank, does it have energy with it? Huge energy. Let the water fall down, it can actually rotate blades and you can generate electricity. That is called, yeah, so that is potential energy. Another definition of it is constraint. Constraint means when you constrain a system, take a bow and you pull the string of the bow. Is it constrained now? Yes. Does it have energy? Absolutely. छोड़ दो फटाक से जाएगा. Watch ring. जो पहले हमारे watch springs होते थे ना. Have you seen बच्चा का those merry-go-round for the kids that they do? You key the merry-go-round and then it cling, 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 cling. So what are you doing? You are actually coiling a spring, and the spring is allowed to slowly recoil. And as it slowly recoil, it moves the gear. With the gear ratio, you will say, sir, spring coils slowly, but the merry-go-round moves fast. Fast and slow, we can do all with gear mechanism. You introduce one gear, so slow. Have you seen those चाबी वाला गाड़ी also? बच्चों को ऐसे करके देते हैं. वो सब क्या है? Potential energy by constraint. Catapult. And these things were known to men. If you see old days movies and all, where they'll say archers shoot. They will shoot, and then also not shoot like that. In grade 7, in 11, you'll learn it's not shooting like this. You're shooting from here. The shooting also does not happen straight. If you shoot at 45 degree, then only your horizontal range is maximum. If you shoot anything above 45 or below 45, वो कम ही होगा. 45 पे maximum जाएगा. Therefore, the general will always say, why? They're still not in our range. Because you still can't reach them. And therefore, in movies, they show all arrows are shot upwards. Then only the range will be maximum. This is projectile motion. This is what a footballer calculates. कितना kick में जाने से सबसे ज़्यादा range में आएगा. And this is what a fighter aircraft, when it fires, he comes down. But when he's come down, he's under the enemy attack. इतना आसान नहीं है. सब कुछ में physics है. So anywhere where you have constrained the system, due to constraint, if you have energy with it, That is also called potential energy. And these potential energy are divided further. In our next class, we'll study into two. One is called GPE, gravitational potential energy. One is called EPE, elastic potential energy. All the constraints fall under this category. Spring, you have pressed a spring. Now, talk, it will fire you back. That is elastic. In grade 9, we will be studying about this. In grade 11, you'll be studying about this. Shanti. Elastic potential energy is whenever a body has been constrained. Like in Bollywood movies, they say, "Ek baar mere haath khol do." So you have tied the guy. That means he is now energized. Once you just open his hands, he's going to bash you. So he's under what? He's under elastic potential energy. ठीक है? चलो.